Okay, so let's keep working through our notes. So number 3 says Mildred has 3 little girls, Margot, Delilah, and Gertrude. If she randomly chooses one of them to clean the kitchen after dinner, what is the probability that she will not pick Gertrude? Okay, so we're looking for the probability of not Gertrude. Okay, so if I'm looking for not Gertrude, Margot is an option, right? She's not Gertrude. Delilah is an option. She's not Gertrude. But I don't want Gertrude. Okay, so how many are not Gertrude? Well, 1, 2. So 2 of them are not Gertrude out of how many total options are there of people to clean the kitchen? So I have Margot, Delilah, or Gertrude. So there's 3 total options. So the probability of not choosing Gertrude is 2 out of 3. That's my probability. Okay. All right. Number 4 says use the following spinner. What is the probability of landing on green? Okay. So we're going to start with the probability of landing on green. Okay. So on top is what I'm looking for. So I'm looking for green. So I ask myself, how many times does green happen? Well, green is on this little diagram 1 time. Out of how many color options are there? 1, 2, 3, 4. So the probability of green is 1 out of 4. All right, so the probability of green. And then it says, what is the probability of not landing on blue? So the probability of not blue. Okay, not blue, which means it can be red, can be yellow, or it can be green. So that can be red, yellow, or green. So there's 1, 2, 3 options out of a total of 1, 2, 3, 4. Okay. So hopefully these examples are helping you a little bit. All right. So now we're going to go on to your practice problems. Okay. And I don't feel like you're quite at a point where you're ready to do the practice by yourself. So I'm going to help you out a little bit first, and then we'll go from there. Okay? So it says write the complement for each probability. Okay? So remember, the probability and its complement equals to 1. Okay? So for example, if this is 3 out of 8, I need it to equal to 8 out of 8, right? Because that's the same as 1. So I'm saying that 3 plus a number equals 8. Or 8 minus 3 equals 5. 5 is my complement because 3 plus 5 equals 8. So a probability plus its complement equals 1. So let's look at the next one. The next one says 7/9. Check my battery life. Okay. 7/9. So again, I'm looking at my bottom number and it's 9. So it's like I have, I don't know. I say cookies a lot, but it's easiest. I have 9 cookies. How many do I have to have all my cookies? Well, 9 of them, right? That makes 1. It makes it complete. Okay, so if the probability is 7 out of 9, so think about like I gave away 7, how many are left? Well, if my total is 9, then 7 plus 2 equals 9. Okay, let's try this bottom one. So again, the probability and its complement equal to 1. 1 is the same as any number on top of the other. So 15 divided by 15 is 1. Any number over itself is going to equal 1. So I have 15 here, and I'm saying 4 plus a number equals 15. So 4 plus 11 equals 15. Okay? So I want you guys to go ahead and press pause, and you guys can do these next ones. Okay, so I've given you 2 of them so you can check all of your work, but I'm sure you did it all yourself, and hopefully we got that all correct. Okay, so now we're going to go down to our table, and it says fill in the sample space and circle the favorable outcomes for each scenario and its complement. Then find the probability. Okay. So this first scenario says, what's the probability of rolling a 5 on a number cube? Okay, so the sample space is all of the options that can happen on a number cube. So 1, 2, 3, 4, 5, or 6. And then we're going to circle or underline. It says the probability of rolling a 5. So there's 1 5. So the probability of a 5 is that there's 1 5 on a number cube out of there's 6 sides, 1, 2, 3, 4, 5, 6. So 1 out of 6. And then the complement, if I'm looking for 5, the complement is not 5. So I cross out 5 and I'm looking for 1, 2, 3, 4, or 6. So if I have 1, 1 plus 5 gets me 6. All right, let's try the next one. So the probability of flipping heads on a coin. Okay, so if I flip a coin, I can either have it land on heads or tails. All right, and it says, what is the probability of flipping it to heads? So heads. So the probability of it landing on heads is, okay, so how many times did I circle? Well, I only circled the 1, so that's heads. Oops, sorry, 1. There's 1 heads on a coin. Out of how many total sides are there? How many options are there? 1, 2. Okay. So again, we're going to do our sample space. So we have heads and tails. So not heads leaves me with tails. So that's also 1 out of 2 because I needed to get my top number to 2. So 1 plus 1 gets me 2. Okay. Next one says the probability of getting a queen in a deck of cards. Okay. So let's go back to our deck of cards. All right, so there's 1, 2, 3, 4 queens. So, but if I can narrow it down a little bit. So if I narrow it down to just 1 suit, right? Because I know it's the same for every suit. So if I narrow it down to just 1 suit, let's see, I have an ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. All right, 1, 2, 3, 4, 5, 10, 11, 12, 13. Okay, good. So there's 13 cards in a suit, okay? And it's asking for the probability of a queen. So the probability of a queen, well, there's 1 queen for every 13 cards, all right? You also could have gotten it right if you said there's 1, 2, 3, 4 queens out of the total of 52 cards, right? Same thing. These are equivalent because 1 times 4 is 4, 13 times 4 is 52, all right? So now my sample space for the complement, so again, I'm listing out all of the possible outcomes. And I want not a queen now. Oops, sorry. Not a queen. So 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. So there's 12 out of 13. And 1 plus 12 equals 13. All right. Let's look at another one. It says the probability of getting a number that is at least 4 on a number cube. Okay, so a number cube, I can roll it and get 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Okay, so now it says a number that is at least 4. Okay, so 1 is not at least 4, 2 is not, 3 is not. Is 4 at least 4? Is 4 greater than or equal to 4? Yes, so 1. 5 is at least 4, and so is 6. Okay, so the probability of at least 4, so greater than or equal to 4. So how many numbers did I circle? I'm looking for the probability of greater than or equal to 4. So I circled 1, 2, 3 numbers. Notice I'm not putting the 4 here. I'm putting how many numbers qualify and fit those specifications over my total. So 1, 2, 3, 4, 5, 6. There's 6 possible outcomes. Okay. And we always need to simplify our probability. So 3 and 6 are both divisible by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So it's a half. So again, if I did it the opposite way, I'm crossing these out, which means I'm circling these. So that can be 3 over 6 or 1/2 as well for the complement. Okay. All right, so you guys can go ahead and press pause and finish this table on your own. There's only 1, 2, 3, 4. All right, and then you can move on. All right, if you were looking at the clubs and you need to look at the cards again, here are the cards. Okay, so it says that there's 13 clubs out of 52 cards, and you can simplify that. And then probability of an even number. Just a little reminder, even, you think about if everybody has a partner, okay? So if there's 2 people, they have partners. 4 people, well, 2 and 2. 6 people, 2, 2, and 2, right? 8 people. So it's like, say you go to the Valentine's dance, right? Everybody has to have a partner. There's no third wheel. There's no odd man out. So that's what even is. It's a number that ends in 2, like 4, 6, 8, 10. And then odd is somebody's left out. So if I go to the dance by myself, it's just me. I don't have somebody to dance with. Or if there's 3 of us, me and my best friend and a boyfriend or whatever, then 1 person is there without a dance partner. So anyways, those are examples of even and odd. All right, so now you're going to go ahead and work through the word problems. Let's make sure that we are text coding. So you roll a die. What is the probability that 2 will not appear? So we are not looking for 2. So I would always list the outcomes. So I'm rolling a number cube. So 1, 2, 3, 4, 5, 6. And the probability that 2 will not appear. So I don't want 2. I want anything but 2. So 1, 2, 3, 4, 5. So probability of not 2 is 5 out of 6 sides. Second one says Tanya has a jar with 15 marbles, 7 are red. What is the probability of selecting a red marble? So probability of red, how many red? 7 out of 15. And complement would be 8 out of 15.